The payload consists of 3 instruments, an IMU, a camera, and the PNDL. The PNDL is Psionic Navigation Doppler LiDAR. It was a technology developed at NASA a few years back, and we have licensed that technology from NASA and commercialized it. And by commercializing it, we've changed the design somewhat to make it smaller and more efficient and with more capability. The optical head is what you see on the front of the vehicle when you're looking at the payload, and it consists of the 4 telescopes that look in different directions. A laser beam is sent out, and fine resolution, velocity, and range are measurements. And by having those measurements from different directions, we can obtain full 3-dimensional vector velocity of the trajectory of the vehicle relative to the ground, and we can also obtain line of sight distance measurements. And from the distance measurements, we can, of course, get altitude.
All right, here we go. Masten ops to all, 6-second count to engine start.
Now we can use that as part of the navigation sensor suite to make very accurate navigation or position and velocity estimates of the vehicle as it's landing. So what that helps is to land in very precise, predetermined locations. For example, landing on the moon next to a crater where water may be present, or repeat landings in the same position for different missions to the moon or other planetary bodies, maybe Mars, in the near future. Working with Masten allows us to advance TRL, the readiness of the sensor. Because it's all autonomous, we can improve the algorithms that are used to navigate autonomous vehicles, synchronize and coordinate all the interfaces with the Masten vehicle such that we have a complete data simulation of landing trajectory. This is only like a first step. A next step, for example, would be to actually start looking at how this data would directly be controlled with the Masten navigation computer, for example. And with the end goal to use this data in a closed loop. And what I mean by that is use the velocity data with their navigation computer to control their vehicle. So we may have photography of the area we want to land, but once an autonomous vehicle is trying to get there, it needs to know where that is in the map.